This is topic 6.4, antiderivatives and the average value of a function. Part 1 is antiderivatives. We're going to begin with finding the antiderivative of the following functions. And as you notice, we're given f prime of x, so we're asked to find the original function. We're given the derivative, and we're asked to find the original function. Now, in order to do that, sometimes it's easier to rewrite the given derivative. So this derivative can be written as x to the 2/5, remember power over root, plus 4x to the negative 3/4 power. Now it makes us finding f of x a little bit easier. I'm going to leave a little space, and I'm going to add 1 to 2/5. And as you can see, I get 7/5. And then I'm going to divide. So we add 1 and divide. Now I'm going to leave a little space and also not write an operator. I'm going to add 1 to 3/4, which would be 1/4. And I'm going to divide by 1/4. So 4 divided by 4, 4 divided by 1/4 is 4 times 4, which is 16. And then, of course, I have to add my constant of integration. Now, as you can see, the given derivative did not include any variables with negative exponents. So it's customary to leave your solutions without fraction exponents or negative, you might think of. So we're going to have 5 times power over root, the fifth, 5 times the 5th root of x to the 7th, all over 7, plus 16 times the 4th root of x plus c. Now, obviously, you can bring 5 of those x's out of that root as 1x. So let's just go ahead and simplify that as 5x times the 5th root of x squared, all over 7, plus 16 multiplied by the 4th root of x plus c. I'm going to go ahead and highlight that just because I sort of wrote into the other problem. You may also see the solution written just like this, so you'll have to recognize either one of them. Okay? Let's go ahead and talk about this next problem. Now, I want you to think about, what did you take the derivative of and get 1 over x? So some of these, we can't use the power rule on a lot of these, right? We have to think about what we took the derivative of to get what they give us. So I know that I took the derivative of the natural log of x and found that derivative to be 1 over x. I'm going to tell you right now, we have to put absolute values on x. We can never take the log of 0 or a negative number, but we have to make sure we put absolute values on that x. Unless it's given in the beginning that x is always positive, we have to do that, okay? So we're thinking backwards. Let's try this one. Y prime is e to the x, and I know that I took the derivative of e to the x to get e to the x. So I just add a constant. Yeah, it's just as simple as that. dy dx equals cosine of x. What did I take the derivative of and get the cosine? You guessed it, the sine of x plus c. Okay, let's go ahead and try this last one. The derivative, and look at this notation, the derivative with respect to x of y is equal to the sine of x. Now think, when we took the derivative of the cosine, we got the negative sign. So I have to take the negative cosine of x plus c in order to have the derivative be the sine of x. So we just have to continue in this fashion, thinking backwards and I think you'll do great with that. Okay, let's talk about an initial condition. And this is an initial condition is a given value of f of x. Okay? So that will actually allow us to get back to the original function without this constant of integration. So if you don't have a given condition, there's an initial condition, there's an initial condition. If you're not given that, then of course you'll have your constant of integration. Let's begin. We're going to go ahead and find the antiderivative first. Everything's set up for us to do that. I'm going to add 1 to 2 and get a 3 and divide by 3, and of course I just get a 1. You can put a 1 there or just leave it as x cubed. We've already talked about the antiderivative of x is 1/2 x squared. That's worth memorizing. 4x plus a constant. Now, let me tell you, I was given f of 2 is equal to 8. Now, you might find that interesting how I did that, but I've always solved these this way because I'm going to plug 2 into all of these. So 2 cubed is 8, minus 2 squared divided by 2 is 2, plus 4 times 2 is 8, plus a constant. So now I know that that's equal to 14 plus c, and they told me f of 2 was 8. So you might want to get in the habit of doing that. So c must be equal to -6. Therefore, f of x is equal to x cubed minus 1/2 x squared plus 4x minus 6. And that is your final answer there, because you've given the original function f of x after someone gave you f prime of x. Let's try that again. Okay? Let's go ahead and find the antiderivative. Before I do that, I'm going to write 3x to the 1/2 plus 3. I notice that I'm given an initial condition, so I won't have to worry about a constant of integration here in the final answer. So f of x is equal to, I'm going to add 1 to 1/2, and I'm going to have 3/2, and then I'm going to divide by 3/2. So that would be 3 multiplied by 2/3. And why don't, for your notes, I just go ahead and write that. Plus 3x plus the constant of integration. Let's take a moment and simplify. 2x to the 3/2 plus 3x plus c. Okay, now I'll go ahead and write this as power over root. Now, I have a question for you. Once I go ahead and find the antiderivative, do I really have to go and do all of the simplification first? Not really. Once you go ahead and find that antiderivative, you can use your initial condition right away. Okay? So I can actually say that f of 1 is equal to 4, and I can go ahead and plug 1 in here, and I know that c is equal to -1. Therefore, f of x must be equal to, and you could write 2x to the 3/2 as 2. If that's an x cubed, under that would be an x times the square root of x plus 3x minus 1. Okay, so the x squared comes out as an x and leaves 1x under the square root. Okay, let's keep going. Now, looking at this next problem, we are given y double prime and y prime, and then they gave us an initial value. They gave us y double prime, and they gave us an initial condition for or a data value, you could say, for both y prime of pi over 2 and y of pi over 2. I think you're going to really like this problem. So let's go ahead and get started. Y double prime is equal to the cosine of x. So it must be that y prime is the sine of x plus a constant. Now, I have taken the antiderivative of the second derivative and found the first derivative. Can I solve for c? Yes. I'm given a data value here, and y prime evaluated at pi over 2 is equal to 2. So this is the sine of pi over 2 plus a constant. And of course, we know that the sine of pi over 2 is 1 plus c. So c is equal to 1. Therefore, y prime is equal to the sine of x plus 1. Now, we're still not finished. I'm going to write y prime is equal to the sine of x plus 1. I'm now going to find the antiderivative of y prime, which is y. Now, we have to be careful because the antiderivative of the sine is not just the cosine, it's the opposite of the cosine, plus the antiderivative of 1 is x, because when we take the derivative of x, we get 1, plus a new constant. Now, I'm going to tell you, I have already used c in the same problem. If you would like, and it's customary to do this, go ahead and call that constant d, because c can't be two different things in the same problem. See if you like that. Now we're given an initial condition of y of pi over 2 is equal to 3 pi. So we have the opposite of the cosine of pi over 2 plus pi over 2 plus d, okay? And of course the opposite, the cosine of pi over 2 is 0. There it is right there. And 0 plus pi over 2 plus d, so d is going to be equal to 5 pi over 2. Because 3 pi is 6 pi over 2, and then we're subtracting a pi over 2. That's how we get 5 pi over 2. And therefore, y is equal to, so we're going to go back up here to this y, the opposite of the cosine of x plus 5 pi over 2. Kind of a cool problem. Okay, let's keep going. I think you'll like this next problem. Particle motion. A particle moves along the x-axis with acceleration a of t equals 12t minus 4. I'm going to go ahead and get that written. The particle's velocity is 18 centimeters per second at t equal to 2. Do you know what we were just given? We were just given an initial condition, okay? So let's go ahead and write down what we were given. The velocity at time 2 is 18. Then it says the initial position of the particle is 8 centimeters. So remember, in motion we write SVA, position, velocity, acceleration. And now, when we find antiderivatives, we're going to be moving up instead of down, okay? So now they gave us S at time 0 is 8. Since they used the word initial and didn't give us a time, of course, we know that that's the initial position, okay? Okay, let's go ahead and start our antiderivative. They would like to know the position of the particle at time equal to 3. Well, they want us to find, let's go ahead and write that out actually, find S of 3. Now we need to find S of t first. Okay, let's go ahead and do this. we're here at A, and we need to go find velocity by finding the antiderivative. Add 1 and divide. Plus a constant. Now, let's go ahead and use that initial condition, V of 2 equals 18. Plugging 2 in here, we get 24 minus 8 plus a constant. So 18 equals 16 plus C. And you can see that C is equal to 2. So therefore, the velocity is equal to 6t squared minus 4t plus 2. Now, you might ask, why does she keep writing this therefore? It actually allows me to go find it in my problem. It's not required, so no worries, okay? So let's go back up here to V of t equals 6t squared minus 4t plus 2. And let me just go ahead and separate all of this. Okay, now we're going to go one more to position, find the antiderivative, add 1, divide, add 1, divide, and now I have a new constant. We were given that S of 0 is equal to 8, so that's 0 minus 0 plus 0 plus D, so it must be that D is 8. Therefore, S of t is equal to 2t cubed minus 2t squared plus 2t plus 8. Now, let's answer the question. They asked us to find S of 3. So it's 2 times 3 cubed minus 2 times 3 squared, 2 times 3 plus 8. And all of that should work out for S of 3 to be equal to 50 centimeters. And that concludes this first part